Okay, I'm going to go ahead and talk now about probability. So in our probability section, it wants us to first determine whether the event is independent or dependent, then find the probability. Slips of papers numbered 1 through 10 are placed into a bag. What is the probability of drawing the number 10 and a number less than 5 with replacement? So we're looking for a number, or the probability of drawing the number 10 and a number less than 5. So the probability of drawing a 10 would be 1 out of 10. We have a key word here. It says and, so we know we're going to be multiplying. And then less than 5, it doesn't say equal to 5, so I'm going to say 4, 3, 2, 1 would be less than 5. So there's 4 numbers less than 5. I'm going to go ahead and multiply these, so I get 4 out of 20. I can simplify that into 1/5, or we can write that as a percentage by simply saying 4 divided by 20. So that gives me 20%. So that would be the probability. 2 students, so number 24, are 2 students selected at random for a class to consist of 13 males and 7 females. What is the probability that both students are female? And that should say, what is the probability that picked at random both students would be female? Okay, so let's see how many total people we have. So I added my 13 and my 7, so I have a total of 20 people in my class. We're looking for the probability that if I picked one student, she would be a female. So my first time that I picked her, she would be a female. The next time that I picked, well, I would have one less person. And since I want to pick another female, I would have one less female. And then I'm just going to go ahead and multiply the tops, which would be 42 on the top. And on the bottom, I'm going to go ahead and multiply my bottoms. So I'm going to say 20 times 19. Which gives me 380. If we can simplify that, or we could write that as a percentage. So we're going to say 42 divided by 380, which is about 11%. There are 24 students in Mrs. Moore's 7th grade class. Each student receives an identical set of marbles as part of a project. Each student selects a marble from his or her set at random. Noelle has developed a model which predicts that the probability of a student choosing blue, so we're focusing on blue, is 0.05. Which of the following events would most likely cast doubt on Noelle's model? Well, the first thing is that Noelle's model has to do with blue marbles. So I'm going to look at my answer choices that have to do with blue. Well, it says that 20 students pick blue marbles. Well, if that was the case, we'd have 20 out of the 24 students pick blue marbles. And if I divide, 20 divided by 24 gives me 83%. Or if you write that as a decimal, 0.83, which is a lot greater than 0.05. So if 20 students picked blue marbles, that would cast doubt on Noelle's model, which says that there would only be 0.05 probability of a student picking a blue marble. Now, the table below shows the results of a survey of a high school boys and girls about their favorite fast food restaurant. What is the probability that a girl chosen at random selects Chick-fil-A as their favorite fast food restaurant? Okay, well, we're talking about girls. Okay, so I'm going to add up how many total girls we have. And then I'm going to say, well, there's 66 total girls. And out of those 66, 29 of them like Chick-fil-A. Okay, so we can try to simplify that. We could also write that as a percentage, and we get 439. So I'm going to go ahead and round up to 44%. Using the same table, we're going to answer A and B. We're going to find the probability that a student selected at random is a boy, given that he likes Taco Bell. Okay, so we're going to go ahead, and it says, given that he likes Taco Bell. So we're going to look specifically at the given part. So they give us Taco Bell. Okay, well, 40 There's 40 people who like Taco Bell, and we want to know if it's a boy. So 30 out of 40. We can simplify that to 3/4, which is also 75%. B says find the probability that a student selected at random likes McDonald's given that it is a female. So again, since we're given that it's a female, we're going to do this out of females. So there's a total of 66 females. And now specifically we want to know about McDonald's. 27, we can do that as a percentage. 27 divided by 66, we get about 41%. Okay. And continuing with probability, Mr. Anderson wants to go to Las Vegas and to Cancun. He has a 45% chance of going to Las Vegas and a 30% chance of going to Cancun. The probability of going to Las Vegas and Cancun is 15%. What is the probability that he will go to Las Vegas or Cancun? So I'm looking for the probability, and I'm going to put V for Vegas or Cancun. And since we have that word or, we know we're going to be having to add our probabilities. The probability that he can go to Las Vegas would be 30%, plus the probability that he can go to Cancun. Actually, the probability they can go to Las Vegas is 45%. Okay, so I'm going to say, let's see, go ahead and erase this 30% and put 45% there. That should be a 45. So we have 45% plus the probability of Cancun, and we have to subtract the overlap. So the fact that he can go to Las Vegas and Cancun. So that would be 15%. And then we can just go ahead, add all these up and subtract the 15. So there is a 60% chance that he could go to Las Vegas or Cancun. 29 says Mrs. Johnson has 11 blue pens, 14 black pens, and 4 red pens in a desk drawer. If she selects 2 pens at random without replacing them, that's going to be key, without replacing them, what is the probability that she selects 2 black pens? Okay, so this is a dependent event because one event is going to affect the next event. So let's first add up how many total pens I have. So I'm adding up my total pens. So I have a total of 29 total pens. And we want to know if she selects 2 black pens. Well, the first time I select a black pen, I'm going to have 14 out of 29. The second time I try to go back and select a black pen, I'm going to have only 28 pens left because I did not replace my first one. And my next one would be 13. And the last part is just to go ahead and multiply these. So we say 14 times 13 would give me 182 on the top. On the bottom, 29 times 28 would give me 812. And lastly, I'm going to go ahead and just write this as a percentage. So we're going to say 182 divided by 812 gives us 22%. 30 says, suppose that of 50 students, 18 sing in the choir, 29 in the school band, and 14 both sing in the choir and play in the band. What is the probability that a student selected at random sings in the choir or plays in the school band? I'm going to write that out, the probability that they sing in the choir. So I'm going to say SC for sings in the choir, or I'm going to put B for band. So again, the key word or tells us we're going to be adding. So 18 of the 50 sing in the school choir, plus 29 of the 50 play in the school band. And then we have a couple of students who overlap in both the band and the choir. So we're going to subtract that overlap, so minus 14. And since they all have a common denominator, that makes it nice. We just write the denominator again and work with the top. So I'm going to say 18 plus 29 minus 14. That gives me 33 out of 50. Or if I write that as a percentage, I'm going to say 33 divided by 50 gives me about 66%. And that finalizes, I believe, our area on probability. The next section will be on statistics. Have a great day.